4th of June, my name's Juan Brown. You're watching the Blancolirio channel. And yesterday, on 3 June, a FedEx MD-11 overran the runway at Mumbai's International Airport in India. Here's what we know so far. Let's check in with Simon Radecki over at the Aviation Herald. Incident: FedEx MD-11 at Mumbai on June 3rd, 2020, overran runway on landing. A FedEx McDonnell Douglas MD-11, registration November 583 Foxtrot Echo, FedEx. Performing flight is FedEx 5033 from Bangalore to Mumbai, landed on Mumbai's runway 14 at 12:14 local, 0644 Zulu time, same as Greenwich Mean Time, but overran the end of the runway by about 9 meters or 30 feet. There were no injuries and no damage to the aircraft. The aircraft was quickly towed off the runway. The METAR for the time of the incident indicates on the 3rd at 7Z, winds at 020 at 13, gust 23 knots, 2,200 meters visibility. That's about a little over 7,000 feet of visibility. That's about 1.3 miles. Light rain showers in the area, a few clouds at 1,200 feet, scattered at 18, and a few cumulonimbus at 3,000 feet, overcast at 8,000 feet. At 6:30Z, they were reporting the winds as 030 at 11, gust 21 knots, same ceilings and visibilities. A lot of science, engineering, and technology is computed into every single commercial operations landing at every airport around the world. Here in the United States, operators are required to do a landing assessment for each landing to each runway. If the weather's clear in a million and there's plenty of runway length, the landing assessment is called standard. You have plenty of runway available to land your aircraft. Through experience, you know that landing distance is not a problem. However, if any of the variables begin to change, you need to carefully assess your landing assessment. And each landing is like being dealt a hand of cards. You need to inspect each and every single one of these cards and put this information into your landing assessment to calculate how close are you to the ragged edge of getting this aircraft stopped in the available runway distance. And every landing assessment is based on the standard application of standard operating procedures, which helps ensure a stabilized approach on speed, which helps ensure a proper touchdown on the proper position on the runway. Ultimately, it's up to the crew to determine how comfortable they are with making this landing at this airport under these conditions. So let's go inside and take a look at some of these details that go into the calculations for every landing at every airport all around the world. One of the first questions you got to ask yourself is, are we legal for this landing? As we saw on the METAR, the wind component was a tailwind component. Generally, manufacturers say that your maximum tailwind component in most of these airliner type aircraft is 10 knots. Now, when you go to do your landing calculation, the landing calculator will tell you whether you're out of limits for tailwind limits as well. But the first thing to figure out is, are we legal? So let's go look at the E6B calcs real quick on these numbers using the steady state wind component versus the gust factor. According to the METAR, at 0630, the winds were reported at 030 degrees at 11 knots, gusting to 21. Looking at just the steady state component of 11 knots, landing on runway 14, that gives us a tailwind component of only 3.76 knots. Now, this aircraft landed 15 minutes later, and the winds were steadily increasing. At 0700, 15 minutes after they landed, the winds were reported at 020 at 13 knots. Let's fix the runway heading here. 020 at 13 knots, giving a tailwind component, steady state, 6.5 knots, 11 knots of crosswind component. At 0730, the winds were up to 20 knots, 020 at 20 knots, giving a tailwind component of 10 knots right up to the limit. And or if you factor in any of the gust factors, which is not required, you can see that at 20 knots, they are at their maximum tailwind limit. Now let's take a look at the Jepson plates for Mumbai. First thing we always look at is the date, 14 June 13, and this is an out-of-date Jepson plate for training purposes only. Up here in the upper left, we see the airport elevation is 39 feet. And here's runway 14. Looks like a whopping 9,419 feet at first glance. But it looks like there's a bit of a displaced threshold on this end of the runway and another displaced threshold on the opposite end of the runway. The touchdown zone elevation on the approach end is 39 feet above sea level. The touchdown zone elevation on the opposite end is 25 feet, so a slight, very slight downslope to that runway. Now let's look at the other side of this page, the 10-9A page. Roll down here to runway 14, and we see the lighting for the runway. We see that it's got a PAPI that's got a 3-degree glide slope and RVR. There's nothing on here that indicates that the runway is grooved. I'll show you an example of that in a minute. But here is some very important stuff. Landing distance, usable landing lengths beyond the threshold is only 8,106 feet, and usable landing length beyond the glide slope, the normal point where you touch down, is only 7,048 feet. So you've lost nearly 2,400 feet of your original 9,419 feet shown here. Because the objective is you have to land beyond this displaced threshold, and if you're following the glide slope, you're going to land slightly beyond, at or beyond the glide slope point. This displaced threshold is because there's some form of obstacles off the end of the runway. Could be these trees and tanks out here that prevent you from using this very end of the runway. If the runway in Mumbai was grooved, it would be shown on the 10-9A page right down here, like in this example for Hayden, Colorado, next to the runway description. Now let's take a look at the Google satellite maps view of Mumbai and the airport, surrounded by congestion. Runway 14. Here we see the displaced threshold. There's the numbers for 14. And here on the approach end, quite a bit of black rubber deposits right here in the landing zone. As we get to the departure end of the runway, where this aircraft slid off, there's another large amount of rubber deposits left behind by landing aircraft. And at the far end of the departure end of runway 14 is the Mithi River, very close to the end of the runway. According to crews that operate out of Mumbai, it's a notoriously slippery runway based on all the rubber deposits that are left on there. Nobody's quite sure how often they clean those rubber deposits at Mumbai. That's a regular maintenance function at most airports here in the U.S. Airline tires are only grooved vertically. Typically, runways are designed to be crowned in the middle to shed water off to the sides, and also often here in the States, they are grooved. The FAA requirements for these grooves on grooved runways are 1/4 inch wide grooves by 1/4 inch deep by 1.5 inches apart, and these grooves are run perpendicular to the runway. Ground-based vehicles like the Blancolirio mobile command post has vertical grooves and siping to help channel the water off to the side. Aircraft tires do not have siping because they would simply wear out too quickly. Each airplane tire needs to go at least 300 landings. By the way, airplane tires are filled with nitrogen and not air. Dry nitrogen. Siping was apparently invented by John Sipe in the 1920s. He was working at a slaughterhouse at the time and got tired of slipping around in his slippery city shoes, so he put grooves in the bottoms of his shoes, and thus the term siping. The reported visibility at the time that this crew landed was 2,200 meters. If we look at the ILS runway 14, and I had to look this one up, CMV visibility, converted MET visibility, minimum is 2,200 meters. So if in the event that the ALS was out, they would be effectively operating right at minimums. If the full approach lighting system was in and the runway visual range transmissometers working correctly, this visibility could be further reduced to 1,400 meters. The bigger point being that this approach was close to minimums, minimum weather requirements, the minimum visibility needed to see the runway. And it's being reported that this crew tried everything they could to get this aircraft stopped by using max auto brake, automatic brakes, and full reverse. So even though everything might look good on paper, you can see this crew is beginning to add everything up against their favor. They're landing on a relatively short runway that's wet, that's not grooved, that's got a lot of rubber deposits on it, flying an instrument approach down to IFR minimums or near IFR minimums. So that means they're breaking out and seeing the runway at the last couple of moments on their approach. And they're probably adding some wind gust additives. Remember, you can add up to 20 knots to your VREF to compensate for gusty wind conditions. And these winds are also bringing them up to nearly their 10-knot tailwind component. So let's take a last look at those final moments of getting this aircraft stopped. Remember, the third form of hydroplaning is reverted rubber. This occurs under heavy braking where the temperatures of the tires become so extreme that the water turns to steam and the hot steam reverts the rubber back to its natural form, melting the rubber, greatly hampering braking effectiveness. And that's what you're looking at in this video. Besides the water being kicked up by the full reverse thrust, you're also seeing steam from the reverted rubber hydroplaning action. So I hope this gives you a better understanding of what happened to FedEx Flight 5033 yesterday in Mumbai, India, and what air crews have to consider every day to make their operations safe all around the world. Pete, congratulations. I see we just passed 200,096 subscribers on the YouTubes. Ching ching. Be sure and check your subscription notifications and make sure it's set up the way you want to. I often get folks that say that their subscription status has changed. It depends if you are subscribing on your mobile device or on your computer or on your iPad. So check your subscription notifications, make sure it's set up correctly. But especially thanks to all the folks over on Patreon that make this content possible. Thanks for your support. See you here.
Kablamo!
That's right.